start a video like that? That's so stupid. We should start with a good Dunkin' Donuts commercial. Oh, that's hot. Nothing beats a good hot cup of Dunkin' Donuts coffee. Right, Polito and Sky? Yeah, I saw you guys with your Dunkin' Donuts. Yeah, wasn't appreciating that the other day. Didn't bring me any, huh? All right, let's get started. Let's talk about this. Today, or for a little while, oh my gosh, let's use pink. Let's use pink, because my name is Mr. Krause. You know I'm going to be Mr. Key for a little while. By the way, this is day 5, Unit 1. Unit 1, day 5. So, we're about halfway through. Well, about a third of the way through. So, let's get started. Linear functions. These shouldn't be bad. These are all straight from, these are straight from 9th grade math, sort of. All right, so we got a y-intercept of -5. We were graphing a line in class the other day, and my kiddies kind of didn't know what to do. It was a little weird and a little disconcerting. So, y-intercept of -5. 1, 2, 3, 4, 5. There it is. And we're going to go up 1 over 3. Up 1 over 3. So the rate of change, or the slope, you're going to hear that word's rate of change a lot. That rate of change or slope is 1/3. Now, there's almost no chance of me hitting any. I'm going to hit one. I got one point. It's really hard to draw a line on my graphics tablet, which is down there, using this fake pen. But whatever. So there it is. There's my graphics tablet. There it is. I got, if you were to talk about domain and range, domain would be -infinity to positive infinity. We talked about that a while ago. Range is -infinity to positive infinity. Now, this isn't interesting. What is the equation of this line graph? Well, the first thing I should do is try to figure out what is its slope. I'm going to use f of x because I think that's a little bit more grown up like. And so let's see what we got. We got a point here and we got a point here. So it looks like it's going down 2 over 1. So that's 2x, and then we got a slope, and then we got to shift down 1. Down 1. Pretty straightforward. That's it. That's the slope. Oh, wait. It's going down. Man, I almost made my first mistake. So it's -2x because the slope is going down. Whatever. All right, so I want to compare these two lines. Well, okay. So we're going to talk about the parent function of a linear function in a second, and then we're going to talk about the transformations of it in just a few minutes. But usually when you compare a line, you compare rates of change. For example, this one has a rate of change or slope. Again, you're going to use that word rate of change a lot, which is really just slope, of -2. In other words, it's coming down. That's a C. Fairly steeply, right? Fairly steeply. Steeply is a new word. It's a new word in the mathematical world. And this one has a positive slope, but its rate of change is, or slope, is +1/2. So it's going up, its rate of change is it's going up, but slowly. And this had a shift down. This went down 1 unit because it's got a y-intercept of -1, so it went down. This one shifted up 3 units. Those are the kinds of things I wanted you to see. You're going to see all those things as we deal with these linear functions right away, because these linear functions are going to allow us to kind of like jump right into some more difficult stuff. So the parent function of linear functions, and I should have probably written this down here, is the line y equals x. Notice there's no y-intercept. In other words, there's no vertical shift up and down. There's also no slope. And when you graph the line y equals x, I always tell kids, first of all, you're going to start at the origin, and then you're going to hit every box on the corners, because it's up 1, right 1, up 1, right 1, so on and so forth. So we're going to hit all these corners of the boxes, just like so. And then we're going to hit all these corners of the boxes like so, going down. And there it is. And that's the line y equals x. No transformations on it. So what's the y-intercept? The y-intercept is y equals 0. What is its slope? The slope is 1. And again, for slope, we're going to call this, and that's what kind of goes in this box right here, but I'm running out to. Call it rate of change. That's what's supposed to go in that star right there, rate of change, but I don't want to move down. So rate of change, that goes in that star. That's what the star is for, rate of change. Domain, well, it goes to the left and to the right forever. It goes up and down forever. This idea of increasing and decreasing. So as we look at a graph and we're looking at it from left to right, if it's going up, it's increasing. If it's going down, it's decreasing. It's relatively straightforward on linear functions. It's pretty easy. It's either going up or it's going down. It can't do anything else. But when we get to some of the other crazy, funky stuff that are going to go up and down and do all this shifts and crazy stuff, we're going to have to really pay attention to increasing and decreasing. And they do a lot of increasing and decreasing work in pre-calc and calculus. So you're going to have to keep an eye on that. But in this case, this is a line that's going up. From left to right, it's always going up. So in other words, it's always going up. So what is the interval by which it's going up? From negative infinity to positive infinity. Where is it decreasing? It's not decreasing anywhere, so we'll say that's the empty set. That's my favorite empty set. And by the way, I forgot to do this. Rate of change, you guys probably know that is the change in y's over the change in x's. Right? You're going to subtract. Some of your teachers do y2 minus y1 over x2 minus x1. It's really just the change in the y values, change in the x values. Is it a function? Remember, we're going to use the VLT to tell if it's a function. Does it pass the vertical line test? So long as you can draw a vertical line through, and you can never hit it more than once. Remember, this line's not part of it. It is a function. So yes, this is a one. Yes, this is a function. Is it a one-to-one function? When we talk about one-to-one function, we now want to use the horizontal line test. And does it hit it only once when you draw in a horizontal line? Yes. So it is also a one-to-one function. Now, is it odd, even, or neither? So if you remember correctly, in order to test if it's even, we look down the y-axis and we see, do we see the same picture on the left and the right? So if this y-axis was a mirror, and you see this over here, do you see a mirror image of it over here? Absolutely not. Absolutely not. But if I was to take this piece of graph paper and spin it 180 degrees, would the graph land right back on top of itself? Absolutely. And because of that, that makes it an odd function. So it is an odd function. All right, so let's keep moving. Two different forms of a line. Oh, yeah. So we talked about this the other day in class. I brought it up in class the other day, and you guys looked at me like I had two heads. So the slope-intercept form is the one you do the most in, I think, Algebra 1. Y equals mx plus b. But, of course, since we're in, like, we're in Algebra 2, we probably should be writing f of x instead of y. But it doesn't matter in this case. Where slope is m. We also have this thing called point slope form. So point slope says you have a, so here's your y, kind of like you have a y here. Here's your x, kind of like you have an x here. And then what we have is slope, and we don't have the y-intercept, but we do have a point that the line goes through. And we're going to be doing a lot with that today and seeing how that works. It's kind of cool, actually. And by kind of cool, I mean only math people would really enjoy it. Okay, I got to take a break so I can get some coffee and refresh my computer, so don't go away. You caught me. Okay, so equations of lines are pretty simple. If you can see that, you can almost always see the slope. Slope's usually not the issue. But take a look at these two graphs. What can we not tell? Oh, good. Nice answer. We have no idea what the y-intercept is. I know the y-intercept is in this area up here. I just don't know what it is. It's probably up a little higher than that. So when that happens, we really can't use y equals mx plus b because we don't know b. Now, you could try to find it. You may or may not be successful. So what we're going to do is we're going to use this equation. Y minus y1 equals m x minus x1, where x1, y1 is a point on the line. You can pick any point you want. In fact, I'm going to use this little point right here. I think that's the fun point right there. We're going to use that point. That point is negative 4. Wait, 1, 2, 3, 4. Negative 4, 1, 2, 3. Negative 4, positive 3. So the other thing we need is this slope. So we can't use this one. We're going to use the slope. So here's a point. So we go up 1, 2, 3, over 1. So my slope is positive 3 because it's increasing everywhere. So it's positive 3. So I have all I need to do in order to find the equation of the line. I'm just going to substitute in this point and this slope into that equation. Now remember, this y and this x don't change. They're going to be the y and the x that you use in that y equals mx plus b formula, so they don't change. It's the x1 and the y1 that change. So here's how it works. You're going to do y. Ooh, I don't like that color. Let me do it down below. So you're going to do y minus the y point, 3, equals the slope, which is 3, times x minus. Now this is why you got to be careful with negatives in Algebra 2 especially. We deal a lot with negatives. That's a negative 4 that goes in there. Well, if you didn't put it in parentheses, you might not realize that's really an x plus 4. All right, we're actually almost done. Y minus 3 equals 3x. Now remember, that's really a positive 4, right? That's really a negative times a negative is positive. So this is really 3 times positive 4 plus 12. Now I'm almost done. I add the 3 over. I'm not going to show that. I'll add that 3 over and I get y equals 3x plus 15. So if you were to look at this and you're like, oh wow, that kind of makes sense. We have a y-intercept way up here of about 15. Okay? So let's take a look at this one. Now this one's not bad. This one over here is not bad. It's kind of by my head though, so maybe I should move that over. Let's take a look at this one. So I'm looking at these 2 points right here. I got a point here and I got a point here. So I can immediately get the slope. Now since it's going down, be really careful. It's going down, so it's got a slope of negative 1/2. And it doesn't matter which one of these points I pick. You know, let's pick this one. That's the point 1, 2, 3, 5. Looks like it's 3, 5. Okay, so we got our point and we got our slope. So now we're going to use our equation. So y minus the y value equals the slope, negative 1/2, x minus the x value, 3. Man, that's not very pretty. Don't like that one at all. All right, let's see what we got here. So this is just y minus 5 equals negative 1/2 x plus negative times negative is positive. This is just 3/2. Oh yeah, it's really 1.5. All right, so then I'm going to add 5. So I add 5 to both sides. If I realize this is really just 1.5 here, I'm going to get negative 1/2 x plus 6.5, right? When you add the 5 over. If you don't like 6.5, put 13/2. I don't really care. There it is right there. There's the equation. Now, does it make sense? We go over 1, up. We go over 2, up 1. Over 2, up 1. So it looks like it's going to cross right about there, which looks like it's about 6.5. So it kind of makes sense. All right, let's take a look. Do I need a break? No, I don't need a break. Do you need a break? You know what I need? I need some more coffee. All right, so we're going to do this one in a slightly different way. Slightly different. Just for fun on this one. So let's see what we got. This point. Now remember, the general equation of a line is this line y equals x. I'm going to make your life a little bit easier on this one. We're going to do this 2 different ways. We're going to do it using the point slope, and then we're going to do it in an easy way. So in this case, my slope is up 3 over 2. So my m is positive 3 over 2. And I'll use this point right here. That point is 4, negative 3. So I do y minus negative 3 equals 3/2 x minus 4. Sorry about that. So this just becomes y plus 3 equals 3 halves x minus. Now, when you multiply a fraction times a number, what you do is divide by the denominator. So we're going to divide by 2. So 4 divided by 2 is 2. And then you multiply by the numerator, which is 3. So minus 6. We're almost done. We subtract 3, and I get y equals 3 halves x minus 9. That's one way to do it. And if I was to show you that calculator, I'm going to bring that up on my calculator. So let me bring my calculator up. I'll put that on my other screen for a second. But there's another way to go about doing this problem. And it's actually quite a bit simpler. Like, really simple. So I'm going to graph that. I'm just going to do 1.5 because that's what 3 halves is. X minus 9. And that's what my line looks like. Okay, so I'm going to get this out of the way. And now I'm going to show you an easier way. And this goes back to the idea of transformations. So let me clear this out a little bit. This line right here is the line y equals x. Now, how do I go from this line to this line? Well, the first thing I'm going to do is take this point and I'm going to move it over to the right 6 units. So we learned before with absolute values, when I go to the right, that's really minus 6. Because anytime you go left or right, it's on the inside of the parentheses, but it's backwards. So if I was to just do this one, I would write y equals x minus 6, because we're moving to the right 6. Now, I also took this line that had a slope of 1, and I changed it. I kind of like, it went from here over to here, but it got steeper. So it moved over, but it got steeper, and it got steeper to a tune of 3 halves x. Now, if I wanted to, I can bring back my calculator. I can do that same exact thing here. Tab 1.5 parenthesis x minus 6. Now, what you're going to find out as soon as I graph this, oh my goodness, what is this? 1.5 parentheses x minus 6. Now, what you're going to find out is that when I press graph, watch the blue line, because there's going to be a red line that pops right over it. It's the same exact line. Another way to do this is I can distribute 3 halves times x is 3 halves x. And 3 halves times negative 6 is, remember we divide, so 6 divided by 2. 6 divided by 2 is 3. 3 times 3 is 9. And if you remember correctly, that's the exact same equation I got on the last one. All right, so let's take a look at this one. Let's find a nice point here. Do you see this point right here? I'm just going to pick one. It doesn't make a difference. So first and foremost, I can see that my slope is negative 1. Now remember, normally our line goes like this. And it goes to this very important point called the origin. So now we're going to figure out what transformations we get to take this point from here to here. Okay? So, what did we do? Well, the slope went from being positive 1 to being down 1 over 1, down 1 over 1. So now we have a slope of negative 1. X. We move to the left 1, 2, 3, 4, 5, 6. To the left 6. Remember, oops, I'm sorry, that's probably behind my head now. So we're going to move to the left 6. That's why we're going to add 6. And then we went down 2, so minus 2. Now, I know you're thinking, it can't be that easy. It really can't be that easy. Okay, let me go back to the point slope formula. Remember, this point was negative 6, negative 2. All right, so y equals, y minus y1 equals m, x minus x1. So our point is this, and remember, our slope was already negative 1. So y minus negative 2 equals negative 1, x minus negative 6. All right, let's see what we got. This is y plus 2 equals negative x, right? That's negative x. And then isn't this a plus 6 right here? This is a plus 6, right? So negative 1 times positive 6 is minus 6. Now, if I clean this up, I just have to subtract the 2 over. I get y equals negative x minus 8. There's the equation. Now, wait, is that the same as this? I don't know. Let's distribute. Negative x minus 6 minus 2. Isn't that going to be the same thing? Wow, that's crazy easy. So quite frankly, while I think this is kind of important you understand, if you can grasp the idea of the transformations, then that's a more important idea for you to kind of grasp, okay? All right, I'm back. Oh, I forgot to have some coffee. When I do rate of change questions, oh, you get it. You know. Anyway, we're going to do rate of change questions. Now, you're going to see this word rate of change so much. You're like, rate of change, rate of change, rate of change, rate of change. Yeah, take your rate of change and never mind. But anyway, the rate of change is really the same as slope. So you remember that slope, which we use, the variable, of course, m, is really equal to the change in y's over the change in x's. Or in other words, it's y2 minus y1 over x2 minus x1. So how do we find rate of change over an interval? Well, if it's a line always has the same slope. So if the line just keeps going and going and going, it will have the slope. So the rate of change, or the average rate of change for any line is really just the slope. So the answer to this question, what is the average rate of change? I'm going to write it right now. Average rate of change is 0.8, or in other words, 8/10. Now, that's not good enough, because what I'm going to ask you to do is to prove it. I want you to show me some work. So the average rate of change is the slope between 2 points. So the first thing we want to do is figure out what our points are. So these, when I give you these are your x values. So we're going to use these as our x values. Now, if you're looking correctly, I have x's, I need y's, right? In order to find slope, it's the change in the y's over the change in the x's. So here's what I'm going to do. I'm going to figure out what the y value is. So y is equal to, by plugging in first a 0, so 0.8 times 0 plus 1. Well, 0.8 times 0 is 0, plus 1 is 1. So my first point is 0, 1. Now I'm going to plug in 10. Y equals 0.8 times 10 plus 1. Well, 0.8 times 10 is 8. 8 plus 1 is 9. So my second point is going to be the point 10, 9. So what I need to do now is, using these 2 points, I now need to find the slope between those 2 points, because that will give me the average rate of change. Again, for a line, it's kind of boring. But when we get to some other cool graphs, you need to remember this. So we're going to do the slope. Change in y's. So I'm going to do 9 minus 1, because that's a positive answer. Makes life easier. 9 minus 1. All over 10 minus 0. 10 minus 0. Well, 9 minus 1 is 8 over 10 minus 0, which is 8/10, which is what I said right at the beginning. So average rate of change is just slope. Okay, now let's take a look at this. Each day, Madeline records the height of the basil plant in her science lab. Her data is shown below. So I'm asking you, what is the average rate of change in height per day from day 1 to day 5? Now, you're not going to average up all these numbers. That's not how this works. We just need to find the slope, and we need to find the slope between day 1 and day 5. An average rate of change. So what we're going to do is we're going to use these. So this is our x values up here, and these are our y values. So our 2 points are really 1, 3.0 and 5, 8.9. And I think we're going to need the calculator for this one. So slope is equal to 8.9 minus 3.0 all over 5 minus, oops, not negative 1, just 1. 1. So what does this become? This becomes, what is this? 5.9 over 4. We probably should get that answer. Where's my calculator? There it is. So we're going to calculator mode. By the way, we should have our calculator soon. 5.9 divided by 4 is 1.475. So my average rate of change, it's positive 1.475. So this would be like centimeters per day. Sorry if that's behind my head. It just says centimeters per day. So that would be the average rate of change just between days 1 and days 5. Okay. So let's take a look at these. These are a little bit different. We're going to have to do these a little bit differently. And hopefully you can just count. So we're going to count. We're going to call this, I'll call this section 1. We'll call this section 2. And we'll call this part section 3. Because each one has a different rate of change. They're changing at a different rate. So you may not remember, but if I wanted the AROC, by the way, I'm going to write AROC. AROC stands for the average rate of change. The average rate of change of section 1. Now, you may not remember this, so I'm going to kind of go through it, and then I'm going to kind of remind you. This is the point -2, -2, and this is the point -4, -2. So if I had to do the average rate of change for this, it would be -2 minus -2 all over -2 minus -4. Well, what this turns out to be is 0 over, well, who cares? Because if the numerator is 0, the answer is 0. Unless the denominator is 0, and then we got other issues. So do you remember that the slope of a horizontal line is 0? Okay, so the slope of that line is 0. So now we're going to talk about the AROC of section 2. Well, if I just look at this, it's up 1 over 1, up 1 over 1. So that slope is positive 1. And then the average rate of change for section 3, down 2 over 1, down 2 over 1. So that average rate of change is -2. Now here's the question. During which interval is the average rate of change the greatest? Now, I want you to remember this. It makes no difference whether it's positive or if it's negative. We just look at the value of the number. For example, if you're on a black diamond skiing, you're going to come down at an average rate of change that's really fast. Okay? It's how fast are you changing? And so you're really just looking for the number with the largest number. So in this case, it's area 3. So in which interval? That would be the interval from 2 to 4, where the average rate of change is the largest. So remember that. You got to remember that it makes no difference whether it's not a negative or positive. It's just which one is the largest. All right. So let's go through a couple of these. Hopefully I don't got too many of these. Once you get the idea of what's going on, I guess you can get kind of catch out. But let's move on. So first and foremost, is this a function? Passes the vertical line test, so yes. Is it a one-to-one function? No, it fails the horizontal line test, so no. Once you say it's not a one-to-one function, I think there's a graph. Is the inverse of this a function? You can't have an inverse. I just wrote yes, but I meant no. You can't have an inverse of a function if it's not a one-to-one, or the inverse of the function is not one-to-one, is not going to be a function unless it's one-to-one. So in order for the inverse to be a function, it has to be a one-to-one function. Domain, it's going forever and ever left and forever and ever right. The lowest number is down here at -8, so it goes from -8 and it's going up to positive infinity. What's the x-intercepts? -6 and 2. Anytime I list out numbers, I list them out in curly braces. What's the y-intercept? Well, the y-intercept is down here at -4. One value. Sorry, I was just calling my wife. The y-intercept is, in this case, what the heck happened? -4. Now, where is it increasing? So here's what you're talking about. We're talking about increasing versus decreasing. So let me erase this. So pretend like you're a ball rolling, right? You're a ball rolling. You're a rolling ball. So if I'm a ball rolling, if I'm going down here, I'm going down, right? So that's decreasing. You're decreasing. You're coming down, so it's decreasing. If I'm going up, this is going to be increasing. Now, let's say Miss Hicks all of a sudden comes into class, and right at the exact time, the ball is right here. We don't know if it was going, what was going on. And we weren't moving the ball. The ball is right there. And someone said to Miss Hicks, is that ball going up or is it going down? Is that ball on the increase or was it on the decrease? And if it's at that exact point, at the vertex of that absolute value function, she couldn't tell you. If she saw the ball here, she'd be like, oh, that's going up. If she saw the ball over here, she'd say, oh, that's decreasing, it's coming down. But if she sees the ball right here at the bottom, she has no idea. So my point is, when you get points like that, and right there at that vertex, do not include the vertex when you tell me the interval for increasing and decreasing. It's really going to become a thing where everybody misses it and you have to remember it. So star this because it's going to be on your test and it's going to be on your quiz. So where is it increasing? And by the way, you always give me X values for these. The only time, and I'm going to say this repeatedly, the only time you're going to give me Y values are for Y-intercept and min and max. Y-intercept and what's the maximum value of a graph. Every other time you always give me X values. So here's how this is going to work. At this point right here, at -2, if I'm on this side, it's increasing. If I'm on this side, it's decreasing. So -2 is the cutoff because we have to use X values. So from -2 to infinity, it's increasing. You can never equal infinity. Let me move that over a little bit. Or shrink this. I don't know if it's probably behind my big fat head. Sorry about that. So you can never reach infinity. And the other thing is you cannot include the -2. Yes, I know that's a point on the graph. You just can't include it on increasing and decreasing. Okay, where is it decreasing? Well, it's starting to decrease at -infinity and coming in this direction, and it stops increasing when it gets to -2. So from -infinity to -2, do not include the vertex. Okay. Where are the Y values positive? Well, all down here, the Y values are negative because we're below the x-axis, which, right, wouldn't you agree that anything down here is below the x-axis? So any Y value between here and here is negative. So I would say starting at -6 and ending at 2, it's negative. Now, at this exact point, it's 0. At this exact point, it's 0. That's not negative. So we cannot include those points. Where does it equal 0? Well, -6 and 2. Again, we're listing values. So where is it positive? Here comes the tricky part. Where is this graph positive? So positive means above the x-axis. Where is it above the x-axis? Well, it starts becoming above the x-axis here or over here. Did you hear me say that word? Or. So it's above the x-axis here or above the x-axis here. Remember what we got with or. So let me show you how that one's going to look. So this means positive. Positive. So from -infinity up through -6, not including -6, or starting at 2 and going to positive infinity. Notice how we got two separate places. Anytime you have two separate places, you're going to have two parts of your interval notation with that U in the middle. All right, we're almost done, at least with this problem. Now, here's min and max. So when you do min and max, Y value. Only time. Y value, min and max, and, range. Range of the Y values. Range and min and max. Okay, so what is the minimum value of this graph? Well, now is when I want Y values. So the minimum value of this graph is -8. And the maximum value, if you notice, it goes on and on forever and ever and ever. So the maximum value of this graph is positive infinity. All right, now we're going to write the equation of this graph. And if you remember correctly, it's the vertex that's the most important thing. So let me move this over. Let's first write that vertex. That vertex is -2, so we went left 2 and down 8. All right, so we're going to do f of x equals, first we're going to check the slope. Slope is up 2 over 1, up 2 over 1. So 2. It's positive because the absolute value is going up, so it's positive. Absolute value. We move to the left 2, so that's x plus 2. Remember, this is always backwards in here. We also move down 8, so minus 8. And there it is. And you can always graph that on your graphing calculator just to make sure you're correct. Ooh, caught me having coffee. Ooh, I got coffee breath. Ooh, it's terrible. Just for, oh, I can't tell you the equation of this line. I'm not going to worry about it. Actually, I can. The equation of this line is pretty easy, right? It's y equals, it's up 3 and over 1, so 3x, and then the y-intercept is 5 plus 5. That wasn't bad. Oh, write the equation of the line. That's the first part. There we go. We wrote the equation of the line. Now the domain. Well, domain's easy. It goes forever and ever left, forever and ever right, forever and ever down. Oops, negative infinity. And forever and ever up. What's the x-intercept? Oh, man, that's crazy. How about we go with 1.75? I should have made that better. Sorry about that. Not really sure what that y-intercept is. I could find it on the graph, but let's not worry about it. I'm not going to worry about it. And the y-intercept is clearly 5. I'm doing terrible with those curly brackets. Is this graph increasing or decreasing in y? This graph is increasing, and it's really increasing because it has a positive rate of change. So a positive rate of change or a positive slope. Where is this? Now again, you guys, when you see less than 0, by the way, this is an SAT trick too. When you see less than 0, again, this is an SAT trick. It doesn't mean less than 0. It means negative. Anytime you see this thing, this is less than 0, it means negative. And wouldn't you agree that it's negative from here down? We're going to assume this point is 1.75. I apologize. I should have made that a little bit clearer. Whatever. So where is it negative? Remember, we're always going to use the x values. So from negative infinity all the way up to negative, this should be negative 1.75. Negative 1.75. So from negative infinity to negative 1.75, not including that, it's negative. Where is it positive? Because again, greater than 0, if less than 0 means negative, greater than 0 means positive. And that's going to be starting at negative 1.75 and going all the way to positive infinity. Again, positive just means above the x-axis. Negative just means below the x-axis. Oh, and where does it equal 0? At negative 1.75. Is this a one-to-one function? Yes. It passes both the vertical and horizontal line test. Yes. That's kind of a silly one. I don't even like that problem. All right, let's do this one. By the way, if you've gotten this and you can go do the homework, go do the homework. I mean, you don't have to see me do all of these, but if you're struggling with it and you want to see me do another one, here's another one. So is this a function? Yes. Passes the vertical line test. Is it a one-to-one function? No, it fails the horizontal line test. Because it is not a one-to-one function, we know for certain that the inverse will not be a function. It can't be. It cannot be. Domain goes forever and ever left and forever and ever right. Range, be careful with the range here. What's the low number? Oh yeah, that's negative infinity. What's the high number? Oh yeah, that's 3. And we include the 3. By the way, just a reminder, where do we use y values? We use y values for range and min and max. That's it. That's it. Don't give me y values on anything else but those two. Okay. What's the x-intercepts? Oh, shoot. Looks like negative 6 and positive 6. What's the y-intercept? The y-intercept is at 3. Where is the graph increasing? From here to here, it's increasing. So from negative infinity to 0, it's increasing. Because at 0, it starts coming down. Now again, if I'm at that exact point, you can't tell where it's going. So we do not include the vertex on increasing and decreasing. All right, where is it decreasing? Starting at 0, going to positive infinity. Where is it negative? Well, if you extended this out here, after -6, it's negative. And after positive 6, it's negative. So where is it negative? From negative infinity to -6, or from 6 to positive infinity. That one's a kind of a tricky one. Where does it equal 0? At its x-intercepts, -6 and positive 6. Where is it greater than 0? Well, it's greater than 0 starting here and ending here. Again, greater than 0 means above. So from -6, ooh, can't do it that way. So from -6 to positive 6, don't include those, because at this point and at this point, it's exactly 0. Minimum value, well, doesn't it go down forever and ever and ever and ever? Yes, it does. So the minimum value is negative infinity. And the maximum value, again, here's where you give me the y values. The maximum value looks like it's 3. Oops. Again, anytime you list out numbers, it's in curly brackets, 3. All right, f of x equals absolute value. Now, since this is coming down, we're going to put a negative out front. Now, is it a -1 or is it negative something else? I got to go up here and count. So I got to say, does it hit all the corners of the boxes or not? It looks like it would hit the corner of the boxes like right here, right? So it looks shallower. So it should be a fraction less than 1, right? So we're going to go down 1 over 2. So my slope, or my average rate of change, is -1/2 x. So I'm going to go back to this. Sorry, I left myself some room. -1/2 absolute value of x. Now, did the vertex move left or right at all? No, the vertex is right here. It just went up 3 units. So I'm not going to put anything on the inside of the absolute values because I did not move left or right at all. But I did go up 3. Because remember, the vertex was supposed to be here, and it got moved to there. So it just went up 3. All right, that's that one. And one last final one. This one should be pretty straightforward. Last one. What's the equation of the line? Let's see. Down 1 over 3. So y equals -1/3 x plus 1. Domain goes forever and ever left, forever and ever right, forever and ever down, negative infinity. That's the second time I've done that. Positive infinity. X-intercept right here at 3. Y-intercept right here at 1. Is the graph increasing or decreasing? Take a look at it. Is it from left to right? Now, from left to right, are we going up or down? And clearly we're going down, decreasing. Decreasing. And that's because the average rate of change, or the rate of change, is negative. All right. Where is it? Remember what this means, negative. And negative means below the x-axis. So it starts becoming below the x-axis here and going in that direction. So starting at 3, going off to positive infinity, it's less than 0. Where does it equal 0? Right here at 3. And where is it? Remember, this means positive. Positive means above the x-axis. I'm not sure if that's behind my head. So let me erase some of this. All of this is above the x-axis, above the x-axis, above the x-axis, above the x-axis, until we get here. So again, that's going to be from negative infinity to 3, but not including 3. Because remember, at 3, it's exactly 0. And these don't have equal signs on them. That's strictly less than or strictly greater than. Is it a one-to-one function? Oh, yeah. It passes the horizontal and vertical line test. All right, kiddos, that's day 5. 5 is German for 5. That was day 5. That's kind of a long day. Not too difficult to work, but some weird stuff in there you got to remember. Only use y values for min and max and range. Any other time we use x values, and we're going to drive that point home as we keep going through this unit. All right, kids, good luck with the homework. Catch you on the flip side. Don't forget to drink Dunkin' Donuts.